We'll start off looking at the production schemas involved in producing live events because they've changed dramatically over the last few years, and you've really got to know quite a bit about the schema and the architecture you'll be using to produce the event before you can choose an encoder. Then we'll look at hardware encoders, software encoders, and then we'll look at transcoders both on-prem and in the cloud. And wanted to start off by explaining kind of how live event streaming, and in particular encoding for streaming, has evolved over the last few years. When we first started producing live events, we would encode a single file on location. We'd send that to a streaming server, and the streaming server would distribute that single file to all viewing platforms. So the file that you encoded on location was the file that actually got delivered to the remote viewer. And that was pretty simple when it came to distributing a single file. But when you were distributing multiple files for adaptive streaming, and you wanted to support both mobile and desktop viewers, you had to encode two sets of streams on site, one for mobile, one for computer playback, and you would send all those streams to your streaming server, and the streaming server would distribute those to the various clients using whatever adaptive streaming technology we were using. Now, the problem with that approach in an adaptive streaming schema was that you needed very expensive encoders on site, right? If you need to encode two sets of 5 or 10 streams each, you're going to need maybe one or two $20,000 encoders on site to do that. Number two, you're going to need huge outbound bandwidth on the location to support all those files that you're sending out to the streaming server. So typically this was okay if you were a broadcaster. You know, you knew this was your business, and you budgeted for it, you had the equipment, you had the bandwidth. But it was a real problem for people who were starting up, and it's particularly challenging for people who are just producing live events from different locations. So if you've got one studio with massive bandwidth and a lot of big iron encoders, you're good. But if you're trying to produce from somewhere else that doesn't have the bandwidth, you're kind of out of the block. So a couple of concepts before we look at how the schemas have changed over the last few years. One is the concept of transmuxing. And transmuxing really came about when, 4 or 5 years ago, everybody was producing for Flash. We produced RTMP streams, either single file or adaptively. But we also know that we needed to support mobile devices. So to support mobile, we needed to change that to an HLS stream, HTTP live streaming for Apple devices. So what transmuxing does is it takes in a single file or a single group of files in a single format, like RTMP, and then it changes the container format and creates any metadata files necessary to distribute that to a different platform. And it's important to distinguish this from transcoding. So there's no transcoding involved. You're using the same H.264 packets. You're just changing the container format and creating the necessary metadata files to support the new distribution technology. So transmuxing is single file or single set of files in, transmux, no re-encode to support a different format. And the first company to do this was Wowza with their, now it's the Wowza streaming engine, it used to be the Wowza media server, and they would typically take in again an RTMP stream, change that for HLS or for smooth streaming or for QuickTime, and send that out. So this gave you the ability to send either one file or one set of files to your distribution server and then transmux at that location so you could support multiple platforms. So that, going back to our, going back to this file here, or this slide here, transmuxing gives us the ability to just set one of these streams to the streaming server and not both, because the streaming server can take this group here and then transmux it to support multiple platforms. So what you've done is you've reduced the encoding requirements on site and you've reduced the outbound bandwidth necessary to support the live event, because you're basically cut out one of these two streams. That's what transmuxing does for you. Now, the second concept is live transcode. And this was also a feature that was probably debuted by Wowza as well, with a product called the Wowza Transcoder. And what the Wowza Transcoder does is it takes a single stream in, and it can transcode that stream into multiple outbound streams in pretty close to real time. So transmuxing is very lightweight, very low CPU utilization, very fast. Transcoding, can introduce maybe between 2 to 30 seconds of latency into the process. Some events that's critical, and most events it's not. I mean, if you're distributing a concert, people watching the concert from 800 miles away don't care that there's a 30-second lag between what's happening at the concert location and what they're seeing. But transcoding is a single stream in, and again, re-encoding that into multiple streams to provide the adaptive streaming experience. So what's happened is, if you look at YouTube Live, and YouTube Live was one of the first to really productize this in a product or service, with YouTube Live, if you want to broadcast, say, a 720p adaptive experience, say starting at 720p and then going down to cellular files, you send them one file between 2.5 and 5 megabits a second, and they do both transcoding and transmuxing to support the different formats. So think about the encoding requirements you needed to support this schema as compared to the schema we saw a few minutes ago where you created all files on site. You can do this with a simple software encoder in a normal laptop, whereas if you were producing the dual sets of adaptive streams, you needed two $20,000 encoders to do that. Okay, so this is what the YouTube Live schema is using. And if you looked at Brightcove, which bought Encoder, which is one of the first service providers for this live transcoding, this is the same schema that they use. And obviously, this is both very efficient from an on-site encoding requirement perspective and an outbound bandwidth perspective. And that's why I think this is a very powerful value proposition for certainly live event producers who are producing at disparate locations. But there's a lot of different ways to do this, right? If you want to roll your own system, you can encode on location multiple files for adaptive delivery, and then use a Wowza media server to transmux that into the multiple formats. And this is a schema that a lot of companies are still doing. Or if you use a product or service like the Wowza streaming engine and Wowza transcoder, you can roll your own or create your own system where you just send a single file in and you can send multiple files out. So we're here to talk about live encoders, and obviously the first thing you need to understand is how many streams do I need to create on site, because that's going to control how much you need to spend and what the configuration options are going to be for the live encoder that you're going to purchase. So the first question you have to ask yourself when you're going to buy a live encoder is, how many streams and what format do I need to create on site? Going to be very different depending on which of these schemas that we use. And again, you need to understand the entire picture of how you're going to encode your files for distribution before you buy your distribution encoder. And with all that said, we can start looking at buying or choosing a live encoder. And these are the various categories that you have to consider, depending on what your encoding needs are. And you can look at this and say, instantly conclude that the rest of the discussion is going to be what we call in the States a mile wide but an inch deep. We're going to cover a lot of different market segments, but we won't have time to really dig deeply into them, because almost any one of these could be a 15 or 20-minute discussion. But if you're thinking about buying a live encoder, these are the various categories you're going to be considering to purchase in, and we'll cover all of those and some buying considerations in each category. Okay, so the first category, and we're going to start with hardware, then move to software, and then move to live cloud transcoding. So the first category is what I call big iron encoders, and these are your $20,000 encoders from companies like Thomson or Atem or Elemental or Digital Rapids, and big expensive pieces of hardware. They can produce multiple files for adaptive streaming on site. So when do you need a product like this? You need a product like this when you have pretty periodic large events or daily broadcasts. So you've got the budget to spend $20,000 because this is your business model. And also, when you need advanced features like advertising insertion, closed captions, access to encryption and DRM, and audio normalization, we call that the COM Act in the United States. This is the only product category that's going to provide those features, or pretty much the only. So if you need captioning real time, chances are you're going to have to buy a product in this class because it's going to be the only product that will support them. And then who are the companies offering products in this category? Atem, you can read the slides as well as I can. Again, this, for anybody who came in late, this presentation is available on my website, Streaming Learning Center. So if you visit the site, the home page, choose Live Encoders up here, and then you can download the handouts right now, or when you get back to your office, whatever. I don't want to name all these because they're up there and you guys can read as well as I can talk. So these are the companies that provide products in this category. And there's some generic considerations that you're going to apply anytime you buy a live encoder, right? You have certain outputs from your camera gear. Maybe it's HDI or HDSDI, maybe it's HDMI, maybe it's component. First off is, does it connect to your camera gear? Does it connect to the mixer that you have? Second is, does it reproduce the required outputs? Which codecs are you supporting, which formats, which metadata requirements? And then can it supply the necessary stream count? Form factor is always going to be a consideration. All the products in this category are going to have remote operation and monitoring via browser-based interface. They're going to give you the ability to create any custom presets that you want, and they're going to be able to schedule broadcasts. All of them are going to claim the best possible quality. I've tested a bunch of these products. We did a bunch of cloud encoding yesterday. All these encoders are going to produce within 2 to 3% same quality. So generally, quality is not going to be a big differentiating consideration between products in this class. What's going to be a big differentiating consideration is going to be the density. We started off saying, how many streams do I need to produce on site? That's the first thing you need to figure out. Once you know that stream count, you need to understand how many of these pieces of equipment do I need to buy to support my stream count. And that's going to vary significantly based upon the different products from the different vendors. And then there's just a range of features that you may or may not need. You've got advertising support, closed captioning support. One of the big ones, over the last 1 or 2 years is it going to be software updatable to HEVC? So Elemental has kind of put a line in the sand and said, everything we do is going to be software updatable to HEVC. We're really a software company, not a hardware company. If you're looking at an encoding solution that uses baked-in H.264 chips as opposed to industry standard GPUs and CPUs and software to encode, then you could be locking yourself into a solution that's not going to get up to HEVC, which I think everybody needs to be considering over the next 6 to 24 months. So this is going to be a big one. If I'm going to spend $20,000, I'm going to make sure that it's going to be upgradable to the codecs I'm going to be using over the next few years. Always going to be, most of the products in this category are going to handle audio normalization, encryption, and DRM, with all of the operational capabilities like redundancy and failover support. Some are going to run Windows, some are going to run Linux. Most in this category are actually working on Linux. And then, pricing is going to vary significantly among all the products in this category, both between the various products and also between the inputs. You're going to pay more for HDSDI than you're going to pay for HDMI or component. And again, I just want to make the point here that if you need captioning, if you need DRM, if you need any of the other features listed here, you may not be able to buy a product in any of the other categories because this is the only, some of the transcoding products do this stuff, but very few of the, these are products in the $20,000 range. All the other products we're going to be talking about are between, $5,000 to $10,000, some a lot less, and they just don't have the features that are available in this class. So if you need captions, DRM, you're probably stuck with a big iron encoder in this price range. Okay, the next class we're going to cover is portable encoders, and you need a portable encoder when you're broadcasting from multiple locations, and you don't want to use a computer with a piece of software, which we'll look at that option in a few minutes. Who is distributing products in this category? Digital Rapids is on the upper right. They've got the TouchStream product. Heyvision has Viper. Viewcast has the 2200 and the 4100. VTech has a pretty neat product, the OptiBase Nano. This is the only product in this class that doesn't have a hard drive, doesn't have any moving parts. What's the benefit of that? Anybody? Pardon? It's certainly easy to transport. It's the size of a ham sandwich. What's the other one?
Moving parts can't break.
One more time?
Moving parts can't break.
Moving parts can't break, and they also don't make any noise. So if you're trying to, if you're broadcasting a deposition or even an event like this, very difficult to have a live encoder, some of these products, because they're computers in very small, very hot boxes, and their fans are very, very loud. So one of the major differentiating criteria in this product category is going to be noise. And another one's going to be, obviously, if these are tied to a system that you're using. So Sonic Foundry has the MediaSite system for learning management and lecture capture. If you're using Sonic Foundry for lecture capture, if that's your overarching system, then you're obviously going to want to at least strongly consider the portable product from that company. And then a lot of the generic considerations are going to be the same, irrespective of which category you're going to be looking at. So does it connect? Does it produce the required outputs? Again, everybody says the quality's great. I think they're all pretty equal. All the products in this category are going to be somewhat, marketing person proof. So you can configure the inputs and the targets, all the stuff you need to configure in the office, make sure it's working, send it out with a non-technical team. As long as they can turn on the cameras, plug in the inputs, and press a button, they can start streaming without having to configure anything. And in my mind, one of the huge benefits of products in this category is just that. Because if you look at a Wirecast or you look at an Adobe Flash Live Media Encoder software programs, you've got to turn the computer on, you've got to run the software. Typically, there's going to be configuration options you need to use to make that work. It's certainly not rocket science, but I would prefer to give a non-technical user a product in this category because it really is one button simple with very good onboard diagnostics to let them know when something's going wrong. And then the advanced considerations in this category, if you're using MediaSite, you want to use a MediaSite recorder. I really like the TouchStream user paradigm, and that's the one that we see in this product here. Where you can just, everything's in the recorder itself. You don't have to bring a monitor. You don't have to bring a keyboard. Very easy to configure, turn on, use, all on site. These three products here, or these other two products here are computers. They've got usually Windows embedded operating system, but you can't access it easily unless you've got a keyboard and a monitor. And that's just another couple of things to bring and another couple of things to break. So you're going to pay more for a touch screen-based unit, but I find it a lot more convenient. And size and weight's going to be consideration. Price is going to be a very significant consideration. As we talked about noise, if you need something quiet, that's something you need to understand going in. And then again, you're going to have to say, do I want Windows or do I want Linux? Because some of these are going to be running Windows, some of these are going to be running Linux. Okay, one of the most fun categories that's come about in the last few years has been the on-camera encoder. When do you want an on-camera encoder? When you're moving the camera around, so you can't use one of the devices we just saw, the big boxes. You don't want to carry those around with you. Those also require power. You need battery operation. If you're producing in an area where there's no Ethernet or Wi-Fi, so you need to use 4G, that's when you'd want an on-camera encoder. Or again, if you need to move the camera around and be really portable. So this is a Teradek cube. So there's actually two systems here. There's a cube encoder and a Bond 4G transmux with 4 4G modems. So this is completely on camera, and this will do your encoding for you, and then this will send this off via 4G to a server that'll reconstruct the packets and then create a stream that you can use for your live streaming. Who's in this category? Live Gear is a very, very popular one with their AirCam. Livestream has the broadcaster, that's the red box. Minicaster, I don't think is represented picture-wise, but they're a German company. And then Teradek, very, very popular company, very, very well-used solutions. And again, that's the Bond and cube in the lower right. Here are some of the generic considerations. Again, I'm not going to spend a lot of time on these. Probably within this category, it's important, do you want one that can actually mount on the camera? And some of these are Wi-Fi only. You want to make sure that it's got a USB port so you can integrate a 4G modem if you want to go 4G. If I'm buying an on-camera encoder, the first thing I want to consider is, does it connect to my service? Livestream is a very competent service. I'm guessing over here it is in the United States. And it doesn't support all third-party products. So, number one is if you're going to be using Ustream or you're going to be using Livestream, you need to make sure that the on-camera encoder you buy can connect to them. And then some of these on-camera encoders can use Wi-Fi, and Wi-Fi is great because it's, obviously it's a very fast transport mechanism. If you're going to be using 4G, typically you're going to want a unit that has multiple 4G modems. So if you look at the difference between so this is the live stream broadcaster. This has a USB port. You can stick a single 4G modem in this device. So if you choose Verizon and Verizon service is clogged that day or there's no Verizon 4G service, you're out of luck. So I don't like single-use 4G devices. What this device does is you can have multiple 4G modems from different service providers. So number one, you have built-in redundancy, right? You've got, if Verizon's down, AT&T is up, or Virgin is up, or somebody's down, but you've got multiple 4G services you can access, and you also can aggregate the data rates to get an overall higher bit rate signal to your streaming server. So if you're going to go 4G, you're much better off using a system that's going to give you multiple 4G modems because you're going to get redundancy and higher bit rates, rather than a system that relies on a single 4G modem.
A quick question on that. Presumably they were working with 4G in the US. Do they work across EMEA?
I'm sorry, do they work what?
In Europe?
I guess I presume so. Is that it? Was that a silly presumption? Does anybody have any experience with these? I know Live Gear for.
The live stream one doesn't.
They need to support the firmware of the USB modem of the specific provider you're using. So they need to make sure that the mobile provider you plan to use, that they're supported in the unit.
Okay, so we're hearing that you need to make sure that the device that you're choosing is supported in the unit that you're going to be buying. So if you, is that?
So it needs to support it needs to have the firmware for the 4G modem you plan to use, and that changes with whichever operator, whichever market you're going to.
So you're gonna buy. This is the easiest example. I mean, you're going to buy this modem from whichever provider you want to use, And then you just need to make sure that this modem is going to be compatible with this piece of hardware. It's a bit more complicated when you look at devices like this where the modem is embedded. But again, I think that's one of the first questions you'll ask, right? Is what service providers are available to me, and can your device communicate with those service providers? In the States, you would get you would just get one of these from Verizon, one of these from AT&T, one of these from somewhere else, and then you would check with Teradek to make sure, hey, can you communicate with these systems? I would assume they could, but anytime you spend that kind of money, obviously you'd want to check. Does that answer your question?
Presumably the order of those is progressively more expensive with that brand order.
They are not. Well, this is the cheapest. This is around 500 US. This is around, I think, as an integrated solution, and it's under 3 or 4. And I think the live gear stuff is the most expensive, but I'm not familiar with their pricing. I think you end up paying more for a system like this because a lot of the stuff is integrated. It's a much neater solution. Some other things I really consider when I'm looking at on-camera devices: does it have onboard SD storage? If you have SD storage, you have the ability to create an archive copy right away. You take that, hand that to the client, they're happy, they can upload that for their on-demand stream. Batteries can be a huge issue, right? So if you got the little red live stream unit, it's got a rechargeable battery. It only lasts an hour. So if your broadcast is 2 hours, you're kind of hosed. So you really need to be thinking, okay, how long do I need this thing to last before I actually buy one? And most of them today are going to have remote control apps that are very nice. You can actually get a confident stream on your iPhone when you're broadcasting. So you can see exactly what's streaming because it's also broadcast to your iPhone. One of the nicer but more expensive units for kind of industrial strength use is the Live Gear Airstream. So this unit has, I think it's 6 integrated 4G modems. It's got a touchscreen interface here, and the really cool thing about it is if you turn it around, it's got 2 battery ports that are hot swappable. So if you're producing a full day live event, you can actually run this continuously just by swapping batteries on the back. So very big consideration if you're producing longer events from on site. And then one of the interesting categories we're starting to see is Wi-Fi or USB ports in some of the more popular ENG type cameras. So this is a JVC unit that I reviewed. You can read the view here. And if you stick a 4G modem into the camera, then you can FTP video files, you can stream live, you can send a stream to a receiving unit in the broadcast site. It's very cool functionality. At some point, units like this may replace the Teradek bond market. The only problem is you're looking at one 4G modem. And again, I don't like one modem solutions because if your carrier's slow that day, you're kind of out of luck, and you can't aggregate the signals to get a really high bit rate signal. So these are really, really cool products, but I think for most producers, you're going to want a cell mux system that has multiple 4G capabilities.
And what kind of encoders do they use on these UGC cameras? Which they have, is it a hardware encoder or is it software?
Okay, so what kind of encoders did they use? These are integrated encoders. So what format does this camera store in? It stores in H.264. So it just uses either the same or a different encoder on board to create a stream that it can stream and then it sends that out. So you're not hooking in an encoder, you're just hooking in the 4G.
They won't do an RTMP encode straight to your DB server. You need a back end, like you're saying, just an RTP stream to a provider who then
That's a great point. What I'm saying here is that the software is still primitive, so they don't. A lot of these today, or this one, when I looked at it, didn't support RTMP output. So you couldn't send it to a live streaming server like Livestream or Wowza. Actually, you probably could send it to Wowza because Wowza does RTP, but these are not as sophisticated as the previous group of products that we looked at that are very tied into distribution infrastructures. These are still like first stage kind of proof of concept products, but I think they'll evolve pretty quickly. I mean, it's not hard, right? Once you have a computer in the camera, what's the difference between an RTMP address and an RTSP type configuration? I think this product category is coming, but again, one 4G modem is kind of scary to me. But they'll, instead of 4G, you can put in Wi-Fi. You put in a little Wi-Fi, this little USB Wi-Fi connectors that are about this big, and then you can send the signal via Wi-Fi, which is a lot better than 4G from a bandwidth and a security standpoint. Not security, coverage standpoint. Okay, if you're producing a live event, there's a good chance you have a hardware switcher, maybe a TriCaster or a Roland unit, and a lot of these switchers are now starting to also support broadcasts to a live streaming server. It's important to kind of parse through the information that you're hearing from the vendors. What Roland does is they can send an H.264 stream out of the USB port of the device. So what do you have to do to the USB stream? You have to put it into a computer and then use the computer to encode and communicate with the streaming server. So it's, they call it a streaming, functionality or an encoding functionality, but it's really, they're really just supplying a convenient output for computer use. They're not supplying an encoded stream. They can't communicate directly with your streaming server. You have to have a computer on site as well. What TriCaster can do is you basically configure in your RTMP server, and TriCaster can send the streams to that server. So you don't need another encoding device. It communicates directly with your streaming server. So bottom line is, if you're wondering how you're going to stream a live event and you've got a video switcher there, find out what capabilities the video switcher has vis-a-vis live encoding. Or, the Roland feature is very, very, it's a great feature. It beats not having anything, but you can't look at the spec sheet says, we support live encoding, and then get to the location and realize, hey, I need something else to really produce this stream and send it to my streaming server. And a couple of specialized solutions, there's a lot of solutions like the WinOff C-Box that are lecture capture solutions. So if we wanted to, to kind of produce this event, we could have a single video stream. We could have my PowerPoint slides going into this box from either a VGA or some other kind of connection, and then we could actually stream the two live, including the PowerPoint and the video. So that's nice if you're producing lecture capture type situations. Sonic Foundry, we looked at their portable box a few minutes ago, and the WinOff C-Box is a box that, that's also very capable in that regard. The other kind of unusual box is if you're streaming from a sporting facility or a concert facility and you want to supply one stream for internal distribution and then also send a stream or multiple streams out to a CDN for external distribution, the DVO Magnus has an integrated Real Networks Helix server, so we can serve streams inside the firewall to people who are watching the game. Very cool, very, very cool functionality if you want to offer it. And it can also send a stream out to the CDN for live distribution. So if you're looking for a single encoder that can kind of handle both those jobs, the Magnus is a fun choice. Okay, so that's the hardware. Let's take a quick look at the software. Pretty busy slide here. High-level messages, if you're using Ustream or using Livestream or using another similar provider, Bambuser is very popular over here, check and see if they have software available for live streaming. So before you go out and buy a Wirecast or some other software program, check with the service provider because you're going to get easier functionality with their software than you would with any third-party software. So if you're using a live streaming service provider, check and make sure that if they have a software program that you can use. beyond that, we covered the video switcher before on the hardware side. There's also a category of products like that on the software side. So a lot of people have heard of Wirecast. It can perform functions like multiple camera switching, transitions, titles. It can play disk-based files, very useful functionality in a live event environment. It can do live green screens, and it can produce virtual sets. So I've never really used these two in a live environment, but if I'm producing a live event, I like titles. I may want to put multiple cameras in there. I don't want to spend $5,000 on a TriCaster, but if I get Wirecast, I can get the same functionality in $500. So these are production switchers in the software side, but they also perform as live encoders. Okay, so there's a couple of the most popular two products I'm aware of are Wirecast, and then Combitech is a European company with VidBlaster, and their products match up very well against Wirecast. They've all got different levels of products that have different levels of functionality. So that's Wirecast on the top, VidBlaster on the bottom. And then here, the considerations kind of go back to normal buying considerations for software programs. Does it support your OS? So Wirecast is cross-platform, Mac and Windows. VidBlaster is Windows only. Is it compatible with the video input cards that you're going to be using? Does it produce the required outputs? They're going to claim superior quality, and I'm sure they're very close to equivalent. One of the nice features that Wirecast provides is it can support multiple formats out. So if you want to, nobody's doing a lot of Windows media streaming, but they can send out a Windows media stream for you as well as a flash stream if you do need to support that. And Wirecast also provides a lot of presets to specific streaming service providers like Wowza or Livestream, Ustream, YouTube Live. And then probably, there's a huge percentage of live events that are produced with the Adobe Flash Live Media Encoder. Why? Because it's free and it works. Microsoft had a product called Expression Encoder that was the front end for Silverlight distribution and Windows Media distribution. That seems to be off the market. But if you wanted to produce in those formats, those are the ones I would trace. That's the product I would try and chase down. And they're really, if you can get what you want from the Flash Live Media Encoder, you can produce up to 3 streams. There's no captioning, there's no DRM, all the stuff we talked about before. But free is good. It's a very good product. I've used it for some events. Why not use it if Flash is what you're distributing? Same generic considerations as before. Is it compatible with your video card? Does it produce the required formats? And then ignore any claims of quality. And then the last category I wanted to talk about is the whole transcoding category. So we looked at this at the start. We said, what's the schema we're going to use to distribute our live files and produce them? And one of the new functions that you can get is both transcode and transmuxing. So if you want to do that yourself, the only on-premise option that I don't want to say only, that's always dangerous, but one of the most popular on-premise options is going to be the Wowza transcoder. And again, you can install that on your own site. You can send it a single stream, and then it can break it into multiple streams for you, or you can install it in the cloud, and then you can send out your stream to the cloud, and there it can split the streams for you, and you reduce the bandwidth requirements on site to get your live event produced. And if you want to do this in the cloud, you have full service providers like Brightcove, Heyvision, iStream Planner to YouTube Live, where you're buying into their system as a whole. They're not doing this as a piece of the production puzzle. You're giving the whole production to them. If you want transcoding only, you can use Encoder, So Encoder is a service provider now owned by Brightcove where you can encode on site, send them streams, and then they will send those streams to your CDN who will distribute using your player. So you can fit Encoder in as a piece of your overall production workflow where all of these options are your production workflow. You send a single stream to Brightcove and they handle the rest. You use the Brightcove server, the Brightcove player, the Brightcove analytics. If you just want to plug the transcoding function into your existing workflow, these are the options for that. Let me stop here and take any questions. Do we have a microphone for questions? No?
Do you always need a streaming server or a typical use case to go from the encoder into the CDN?
Okay, so the question is, do you always need a streaming server, or does the typical use case go from encoder to player? I think in almost all instances you need a streaming server. Is that right? Anybody? I mean, there are some point-to-point, but they're very specialized. But if you want to stream to a bunch of different people, then you're going to need a streaming server.
What was the relationship between Encoder and Brightcove?
Say it again?
What was the relationship between Encoder and Brightcove?
Brightcove owns Encoder. So Brightcove bought, so what's the relationship between Encoder and Brightcove? Brightcove bought Encoder, I want to say 18 to 24 months ago. So they are still offering both live and on-demand encoding as a separate service, exclusive from Brightcove. But if you use the Brightcove live streaming service, you are using the Encoder functionality. You don't know it because it's all Brightcove interface, but Brightcove takes the signal, uses their capabilities to transrate and to transcode and transmux, and then sends it out through their system. I guess the point I was making is these are full service providers. They do everything for you. They create the player, they do the server. If you just want to plug transcoding into your existing workflow, you'd want to look at one of these two options. So you send them a stream, they produce the streams and send that off to your CDN, and then you can plug that back into your.
From a business perspective, is the Encoder still going to be around? Is there not risk that Brightcove will stop that independent service?
So the question is, will Encoder be around? My sense is they will be, because I think they perform a very useful function that's very independent from the core business unit of Brightcove. Brightcove doesn't want to get into the file transcoding business for VOD or live, but Encoder I think is doing pretty well in that market. And I spoke to the Encoder guys last week in preparation for my cloud talk yesterday, and it seems like they're operating very independently and they're pursuing their own goals and visions. So I would think they'd be around separately. Anybody else?
So if a customer comes to you and says, or somebody comes to you and says, they want to stream low latency streams from.
I'm sorry, they want to stream what?
Low latency streams, like really low latency, like end to end.
Okay.
They want to stream in real time. Say it's a casino, for example, and they want to do online bets or something, and they want to stream it in low latency from the encoder to the player. Have you come across a solution that will actually provide this sort of?
So the question is low latency point to point. I think
Point to multi-point.
point to multi-points. You've got to. I mean, there are point-to-point solutions, but I think you're looking at it. It's a different class of product, right? You've got, the Matrox has a product I think called the Mavis or Maven, something like that, where it's it's an encode decode. They can communicate directly, HDSDI in here, HDSDI out here, so you get very, very fast, broadcast level type production. But that's not one-to-many, because for live streaming you need a streaming server to do the distribution for you. So, anybody know anything else that I'm not? Okay, any other questions? Okay, thanks for your attention.